Hello. Today we're going to be looking at lesson 4-7, scatter plots mini lesson. A scatter plot is another way to display data. Typically it's going to show you a relationship between two different sets, and you're trying to identify whether or not there is a correlation. So when we look at the definition of correlation, which is our second definition here, it says it describes a relationship between two sets. There are situations where you can have a positive correlation, a negative correlation, or no correlation. Once you determine that there is a correlation, if there is one, you can draw a line of best fit, which is the line that comes closest to all of the points on the scatter plot. Basically, it's showing the direction of the data and giving you some information about the correlation. So let's break these down. So first of all, a positive correlation, as you can see here, both sets of data either increase or decrease together. Now this can often be confusing. That would mean as one data set's going up, the other's going up, or as one data set's going down, the other set is going down. Both of those are positive because they're showing a positive correlation between the sets. The sets are moving in the same direction. Conversely, a negative correlation, as we see over here, is sloping downwards. And it's the values when one set increases, the other will decrease. And we'll talk more about this in a minute down below. So that means as one set's going up, the other's going down, or as one set goes down, the other one goes up. And then occasionally you'll have a data set where there's no correlation. So the points neither increase or decrease together, and they look like a random scattered amount of points. Now occasionally you might have a positive correlation that you don't consider to be extremely strong, meaning they are generally going up together, but it's kind of more spread. That could be considered a weak positive correlation, whereas this one here would be a strong positive, and this one here would be a strong negative. So in example 1, it says, write positive correlation, negative correlation, or no correlation to describe each relationship. So we don't actually know what this is necessarily plotting, but we can see that the x-axis is labeled temperature and the y-axis is labeled sales. And roughly speaking, we can see that this is a positive correlation. As temperature increases, so do the sales. Now, for those of you that might have been confused up above when I said that also means they could both be going down, think about it this way. As the temperature decreases, so do the sales. So if you follow this way, down at the bottom, the sales also go down. So in other words, it doesn't matter which way you start. If they're going in the same direction, the correlation ends up being positive. On the other hand, in the second example here, it says length versus success. And what we can see here is as the length increases, the success decreases. So you can see, generally speaking, a negative correlation there. So as one set goes up, the other is going down. And you could look at it as the success increases, the length is decreasing. So they're going in opposite directions. So again, we would write down here positive correlation for the first one. And these are both fairly strong. Not that you have to note that, but. And a negative correlation for the second one. Okay, next we're going to actually create our own scatter plot. So in example 2, it says, complete to determine if the two data sets show a correlation. Make a scatter plot, draw a line of best fit if there is a correlation. So we can see here we have the time of the day and the sales, quantity of sales, and we already have our axes labeled here. So what we're going to do is just match up as close as we can where the time matches the sales. So for the first one here, we have 1 o'clock, 130 sales. So at 1 o'clock, I'm going to just drag my finger up and try to get it as close to 130 as I can. 130 that is. At 130, we're at 125. So 130 is going to be right around here. 125. Okay, at 3 o'clock, 150. $3.30 was 155. $4 o'clock, 150 again. $5.30, 165. $6.30, 180. And 7 o'clock, 195. Okay, so as you can see here, we can determine that generally speaking, the time, not that this is a strong correlation necessarily, but the time is increasing. And as the time is increasing, so are the sales. So sales are also increasing. And therefore, if one's going up and so is the other, that means they're going in the same direction. And that is a positive correlation. We also are asked here to draw a line of best fit. And also, as when we're making any graph, really, we should always include a title. So even though we don't have a whole lot of information here, we could just simply say time versus sales. And the line of best fit, I always try to get about the same amount of dots above the line as I have below the line, and still, of course, show the direction. So right through there, approximately, and it is a line, so it will have arrows. Okay, and then the last example here says, do the data sets show a positive, negative, or no correlation? And we're going to determine this without graphing anything. So first, a person's age and the number of pairs of shoes they own. So you might think, well, you accumulate shoes as you grow older, but that's not necessarily true. Some people might be older and have a ton of shoes, and some people might be younger and have a ton of shoes. I just saw my friend whose 4-year-old has 69 pairs of shoes. So you just never know. So for that reason, I don't think we can actually determine if there's a correlation here. So we would say no correlation between a person's age and the number of pairs of shoes they own. Next, the decrease in temperature and the number of people wearing winter hats. So as the temperature outside goes down, the amount of people wearing winter hats we would think would generally go up. And because we can make that assumption with a strong enough feeling, we could say that one's going down while the other's going up, which is a negative correlation. And lastly, the number of logs in a fire and the amount of time before it burns out. Okay, so if you take logs off, so in other words, if the number of logs went down, the time before it burned out would also go down. If you keep adding logs to the fire, the time before it burns out will also increase. So whether they're both going down or they're both going up, they're increasing and decreasing together. So since they're going in the same direction, we would consider that a positive correlation. That's it.